Hello, I'm Brock Tice of CardioSolv, and today I'm going to be demonstrating to you how to use our web interface, the CardioSolv Simulation Manager, to initiate a spiral wave in a sheet of tissue. When you first log into the CardioSolv Simulation Manager, you'll see the simulation screen. That's what's here. I have one existing simulation which I was pacing a sheet, but we're going to go ahead and create a new simulation for this demo. Call it plane wave. We'll use our simple mesh, which is just a sheet of tissue. The pretty standard Lorudy dynamic model from 1994 is the ionic model. And we'll assign the tissue region. So the way this works is we have configuration regions, and then you can assign one or more tissue regions to each set of ionic model conductivities, and there are more advanced parameters too that aren't being shown right now. Our simulation is going to last 500 milliseconds, and should give us enough time for the sheet to move across, or for the wave to move across the sheet, and then have the recovery wave so that we can stimulate in the tail and create a spiral. I'm going to add an electrode along the edge, pace with transmembrane current starting at 0 milliseconds, for a duration of 1 millisecond, an appropriate stimulus strength. I'm going to show advanced mode. You can switch between bidomain and monodomain just using a checkbox here. We're going to stick with monodomain for this since it's just propagation. I'm going to add checkpoints. This is currently an advanced parameter. Okay, and then we can hide that, save our simulation, and run it. Okay, you can see from the status information here our simulation is running. Currently progress is 0%. At the top of the results screen here there's a little summary of what we're doing in the simulation. You can see the end time, time step, that it's a monodomain simulation, some information about the mesh, and the stimuli that are being applied, as well as the regions with the specific conductivity information here. You can view the PAR file, should that be of interest to you. This shows a detailed set of all the parameters that are being passed to the CARP simulator. You can view the log file, which right now you can see nothing is, there are no time steps yet. They'll show up here probably once I refresh. The checkpoint's already been written. And I'll go ahead and refresh so we can get something meaningful in the traces. Okay, still running. We are now at 4.4% of the way through the simulation. Again, in the log file you can see here some time stepping information. Now if we look at traces, you can see a trace of the transmembrane potential, and these traces are taken at various points throughout the model. So this is probably near the electrode, but we're going to see later some additional waves popping up throughout the tissue. And check like so. Okay, I've skipped ahead a little bit so that you don't have to wait for my slow demo server. But you can see now we've reached 23.8% progress, still running. If we go and look at the traces, you can see we have our first action potential recorded on these traces. Of course, there have been others. These points are just sort of distributed across the tissue, so they may or may not pick up the initial stimulus. But you can see now that we clearly have at least one node activating. And in fact there's a line of them. Okay, the simulation is finished. You can see the log file. You can download the data file called an IGB file. Normally you could download the extracellular and intracellular files, however this is a monodomain simulation, so only the intracellular, or really transmembrane only the transmembrane file is available here. We can still look at our traces, which now show basically a wave going across the tissue. A movie is being generated right now. You can still hear the server in the background. It got a little warm. Okay, now the movie is finished being generated. We can watch a movie and ensure that what is happening is what we want it to happen. Sure enough, there is a plane wave moving across the tissue. Now we want to figure out from this where we should apply our cross stimulus. It looks like about 2/3 of the way through the simulation the wave is across the sheet. Or the tail of the wave is where we want it to be, really. So let's go ahead and generate the next simulation. I'm going to duplicate this one so that we don't have to worry about any of the parameters changing. We'll call this cross stimulus. We're going to load checkpoints here, and we have our checkpoints from the plane wave simulation available, as well as one from pacing, but we're not going to use that. The simulation is about 500 long, so we want to try at about 300 milliseconds to add this cross stimulus. And we're going to, again, run until 500 milliseconds, so it'll be from 3 to 500 milliseconds. In this case, the pacing stimulus is going to be along the Z edge. Again, a transmembrane current, otherwise the same parameters, but we're going to start at 300 milliseconds. And this should be good. Let's save the simulation, run it. And you can see our new simulation is running, restarting from this checkpoint. Here we can see from the traces that there's a new wave starting. That's a good sign, considering we're stimulating the tissue again. Of course, if there were a reentrant wave, you could see this too, but as we saw from the last simulation, there was no reentrant wave when we finished. So this is likely to be from our new stimulus. Okay, our simulation is done. We're still waiting for the movie to be generated. We can check the traces here. And indeed, we have some new activations following the new applied stimulus, so I expect to see something, even if it's not a spiral wave, once we look at the movie. There we go, the movie's ready. Here we can watch it. And looks promising. Yep, I think we have a spiral wave. Okay, well now we can let this run a bit longer. Again, we'll duplicate the existing simulation, call this spiral wave settling. I'm going to find an appropriate checkpoint here. Now we want from the cross stimulus, the last one, and we will let this run another 200 milliseconds. So 500 plus 200, the absolute end time is 700 milliseconds. We're going to delete our stimulus since we just want to let it settle. Save the simulation. We'll get a warning that there are no stimuli, lest we accidentally run a long simulation that does nothing. And now I'm going to run simulation again. So here you can see that this simulation inherits from the cross stimulus simulation, and there's actually direct links to the setup and the results of that. It tells us which state file we're restarting from. And again, the details. Here you can see there are no stimuli. Probably that should say none. And now we have some traces. Not much to look at yet. I'll let this run for a little bit and then we'll come back and check on it. Here we're a quarter of the way through the simulation. We're still seeing new activations, which is a good sign that our spiral is probably still going. So we'll wait a little bit longer and see how things go. Okay, our simulation's just about done. 95.5%. We'll wait another minute or two and it should be done and have a movie ready for us. So I've waited for our simulation to finish, and you can hear the server is quieted down in the background now. Again, stimulus or the status is finished. You can see our movie has been generated, and if we watch the movie, you can see there's a spiral wave going around. Looks like it's pretty stable. It's not completely stabilized yet. There are some conduction velocity heterogeneities here, but for the most part, it's stabilized. We could certainly let it run longer and see. Anyway, as you can see, it doesn't take very long, nor is it very difficult to set up a spiral wave in a monodomain sheet using the CardioSolv simulation manager. If you have any questions, please feel free to contact us. Thanks.